trig functions take an angle as input and output the ratio of sides. For example, opposite side divided by hypotenuse side. But how do you evaluate trig functions without drawing triangles and measuring lengths of sides? Well, you can use your calculator. You can type in your calculator sine of 60 degrees, or, so that's if you're in degree mode. If you're in radian mode, you could type sine pi divided by 3 and get the same thing. You'd get 0.8660 and so on. This decimal expansion hides the fact that sine of pi over 3 is a nice neat number. It's square root of 3 divided by 2. And we're going to want to know these nice exact values for certain angles. In particular, we want to know the exact value of trig functions for multiples of 30 and 45 degrees because they have nice expressions like this. So you have to come up with some way to remember them. Here's one way, using the unit circle. So let's first of all think about some points you already know on this circle. If we plot this unit circle, which remember is a circle with radius 1, if we plot that down on an xy plane, then this point right here is x equals 1, because it's over 1, y equals 0. This point is 0, 1. This is negative 1, 0. And this is 0, negative 1. I suggest that you remember these 3 points here. I'm going to tell you what they are. This one here is root 3 divided by 2, comma, 1/2. This one is root 2 over 2 divided by root 2 over 2. And this one is the switch of 30 degrees. It's 1/2 and root 3 over 2. So I suggest you remember those 3. Then, if you wanted the coordinates of one of these other points, and I'll tell you why you'd want them in a minute, you can just use the fact that the x and y are going to be similar, maybe with negative. For example, this angle over here, which is 1, 2, 3, 4, 5 lots of 30 degrees. So that's 5 times 30 degrees, which is 5 pi over 6. That's this angle here. It has the same y value as 30 degrees. And it has the same x value too, except it's on the negative side. So the coordinates of this point are negative root 3 over 2, comma, 1/2. Similarly, this one here is negative root 2 over 2, root 2 over 2. And you can do that for any of the other multiples of 30 or 45. So again, just needing to remember these 3. But I haven't yet told you why you would even want to know these coordinates. Let's look in at a specific angle. Let's look at 30 degrees. And let's draw that right triangle that we use to determine sine and cosine. So here's theta equals pi over 6, or 30 degrees. Here's the adjacent side. Here's the opposite side. And here's the hypotenuse side. Let's clear that out of the way. We can figure these out based on the coordinates of this point. And here's how. Well, first of all, the hypotenuse side, that's just a radius of this circle. So the hypotenuse is 1 because the radius is 1. The adjacent side is exactly how far over this point is. It's exactly the x value of that point. And the opposite is exactly the y value of the point. It's the height of this point right here. So if I wanted to know what, for example, the sine of 30 degrees is, the sine of pi over 6, it would be opposite over hypotenuse, which is the y value of the coordinate of where the angle hits the unit circle divided by 1, which is just the y value. The cosine of pi over 6 is the adjacent over hypotenuse, which is just x over 1, or just x. And in fact, this is going to be the case not just for pi over 6, but for any angle on the unit circle. We have that if you call x comma y the point where the angle hits the unit circle, like this point right here would be the point where this angle hits the unit circle, then the cos of that angle is the x coordinate. The sine of the angle is the y coordinate, and the tan Well, tan is sine over cos, so it's just y divided by x. For example, if I wanted to know 180 degrees, that's pi radians. If I wanted to know the tan of pi radians, that's sine of pi divided by cosine of pi. That's the y value over the x value, which is 0 divided by -1, which is 0. The other three trig functions are defined in terms of sine and cos, and so you can use them in the same way. Cosecant is 1 over sine, that's 1 over y. Secant is 1 over x. Cotan would be x over y. So just knowing the coordinates of the first quadrant, you could get the coordinates of all the other multiples of 30 and 45, and then you can figure out the sine, cos, and tan, cosecant, secant, cotan of all of those angles in exact value.